Hi there, it's Professor Shannon Gracie. Today we'll be covering section 13.5, Systems of Nonlinear Equations in Two Variables. This is from the Blitzer Introductory and Intermediate Algebra for College Students text. And if you need some review, you can always go to the Introductory Algebra site and do sections 4.2 and 3 relate to systems of linear equations in two variables. So here we go. We'll be warming it up by solving a system of linear equations in two variables, and then we'll move into using the substitution and addition method in order to solve the nonlinear systems. So here we go. If we just kind of name this equation A and equation B, our first step, if we're using the substitution method, would be to, let's go ahead and isolate y in equation A. I think that'll make things nice. So here we go. Equation A is x plus y equals 6. So y is equal to 6 minus x. So then our second step would be to substitute y equals 6 minus x into, and be sure you use the other equation. So in this case, it would be equation B. So equation B is 4x minus y is 4. So we would have 4x minus 6 minus x is 4. So all I did was y is equal to 6 minus x. So now we have a linear equation in one variable, which is review stuff. So we've got 4x minus 6 plus x is 4. So that would give us 5x minus 6 is 4. 5x would be, adding 6, I would get 10. And dividing both sides by 5, I'll get x is 2. All right, halfway there. So third step would be to substitute x equals 2 into equation A. I think that will be easiest. So remember that equation A was x plus y is 6. So 2 plus y is 6. So all I did here is I plugged in 2 for x. And then when you isolate y, you get y is 4. So fourth step would be a short conclusion. In this case, the conclusion is just that we found the ordered pair. 2, 4 is where these two lines intersect. Okay, so here we go. Again, if you name this equation A and equation B, the first step, if we're solving by the addition method, this is sometimes called the elimination method, you need to write that line in general form. So rewrite equation B in general form. Basically, you want the constant on one side and the variable terms on the other. So x equal to 2y plus 4, if you subtract 2y from both sides, you get x minus 2y equals 4. So what has that given us? That has given us the equivalent system of 2x minus 4y is 3. And then our equation B, let me make this bigger here. Our equation B is going to now be x minus 2y is 4. So again, equation A, equation B, in a format that's conducive for addition method. So second step would be, okay, we want to eliminate one of the variables. So why don't I multiply, why don't I add equation A plus -2 times equation B, and that's going to eliminate x. So 2x minus 4y equals 3. That's equation A unchanged. If I multiply each part of equation B by -2, I'm going to get -2x plus 4y is equal to -8. So now what's going to happen? So when I add those, what happens? Do you see that we're going to get 0x's plus 0y's is equal to -5. So 0 times anything is 0, so we get 0 is -5, which is definitely false. It's a contradiction. So if you get a contradiction, what does that mean? That means there is no solution. So in this case, the third step will be our conclusion. And the conclusion is that there is no solution. So this means that these graphs do not intersect ever. Okay, so here we go. A system of two nonlinear equations and two variables also called a nonlinear system, contains at least one equation that cannot be expressed in the form ax plus by is equal to c. A solution of a nonlinear system in two variables is an ordered pair of real numbers that satisfies all equations in the system. The solution set of the system is a set of all such ordered pairs. As with linear systems, the solution of a nonlinear system, if there is one, corresponds to the intersection, and there might be more than one intersection point. So you could have multiple solutions of the graphs of the equations in the system. Okay, so we are being asked to solve this system by the substitution method. So here we go. Equation A, equation B. So notice that y is already isolated in equation B. So let's do this. Substitute y equals x squared plus 1 into equation A. So equation A is x minus y equals -1. So we'll have x minus x squared plus 1 equals -1. So y was this. Okay, so now we will have x minus x squared minus 1 equals -1. So if I get everything on, actually, why don't we just bring that -1 over? So if I add 1 to both sides, I'm going to end up getting x minus x squared is 0. So now we can factor out an x, and we'll get 1 minus x, and those factors are both equal to 0. So we get x is 0 or 1 minus x is 0, which would give us that x would be 1, or 1 is x. So here we go. We got two solutions for x. So our next step will be to substitute x equals 0 and x equals 1 into, what equation was the easier one? Probably into equation B. That's where y is isolated. So y equals x squared plus 1. So for x equals 0, we'll have y equals 0 squared plus 1, y equals 1. For x equals 1, we will have y equals 1 squared plus 1. So y will equal, good, 2. So what did we find out? We found out that the set of ordered pairs, we got two different solutions. So we got a solution at 0, 1, and a solution at 1, 2. So these graphs intersect at those two ordered pairs. Good so far? Great, awesome. All right, so our next problem, again, we're solving using substitution, were the instructions. So if we name this one A and this guy B, our first step will be substitute. I guess we'll do y equals x squared plus 2x minus 1 into equation A. So we'll have equation A is y equals x squared plus 4x plus 5. And for y, we're going to put x squared plus 2x minus 1 and set it equal to this. So this is what we did. This is what y was equal to. And now let's go ahead and get 0 on one side. So if we subtract x squared, subtract 2x, and add 1. So subtract x squared, subtract 2x, and add 1 from both sides. What we will have is 0 on the left side is equal to the x squared 0 out, and then we'll get 4x minus 2x is 2x, and 5 plus 1 is 6. So negative 2x will be 6. Dividing by negative 2, we'll get x is negative 3. So the next step, substitute x equals negative 3 into equation, guess we could just do equation B. So we'll have y equals negative 3 squared plus 2 times negative 3 minus 1. So y will, and by the way, I had x was equal to negative 3. You know what? Let me write the original equation I'm using up top so you don't get confused. So I just plugged in x equal negative 3. So that will give us 9 minus 6 minus 1. So y will be equal to 2. So this time we just got one ordered pair. So let's put our conclusion down. So we found that the ordered pair negative 3, 2 is where these two graphs intersect. Okay. And then part C. Call this guy equation A and equation B. Our first step is, let's see, why don't we go ahead and isolate x, I guess. So isolate x in equation A. So, oops. So we'd have x times y is negative 12. So x would be negative 12 over y. And then what we need to do is we need to substitute x equal to negative 12 over y into equation B. So equation B is x minus 2y plus 14 equals 0. So we'll have negative 12 over y, because that's what x is, minus 2y plus 14 equals 0. So if we want to clear out the fraction, we can multiply everything by y. So that would give us negative 12, negative 12, because we're distributing that y to each term. So we'd get negative 12 minus 2y squared plus 14y equals 0. And then if we factor out a negative 2 and then write them in descending order, we'll have y squared minus 7y plus 6 is 0. So then if you just divide both sides by negative 2, those divide out. So we get y squared minus 7y plus 6 equals 0. Factoring, we get y minus 1 times y minus 6 is 0. So y minus 1 is 0, or y minus 6 is 0. That would give us y is 1 or y is 6. So we got two solutions for y. So now, if we go ahead and come back over here, substitute y equals 1 and y equals 6 into equation A, which was xy is negative 12. So for y equal to 1, we'd have x times 1 is negative 12. And that would give us x is negative 12. For y equal to 6, we would have x times 6 is negative 12. So x would be negative 2. So this is substituting y is 6 into that original equation. So we got two ordered pairs for our solution. So our conclusion will be the set of those ordered pairs. So we have, what did we have? We had negative 12, 1. And then we had negative 2, 6. And you're done. Okay, so the next skill is to use your solving using the addition method or solving using elimination. All right, so here we go. We have our equation A and equation B. Remember that with the addition or elimination method, what you want to do is you want to eliminate a variable. So you have to have opposing coefficients that are opposites of each other. So when I look at the x's, they won't work in this problem unless we adjusted them. Now let's look at the y-squareds. Do you see they have opposing signs? You've got a negative here and a positive here, and they're both ones in front. So basically what we can do for our first step is we're just going to add a plus b, those equations, and that's going to allow us to eliminate the y squared. So let's do it. We've got 4x squared minus y squared is 4. 4x squared plus y squared is 4. So adding, we get 8x squared is 8. Dividing by 8, we'll get x squared is 1. And then square root both sides, and you get x is good, plus or minus 1. So now if you go over here and you substitute x equals negative 1 and x equals 1 into equation, probably A, it doesn't really matter, then we'll have the equation is 4x squared minus y squared is 4. So we'll have 4 times negative 1 squared minus y squared is 4. And that's for x equal to negative 1. And that will give us just 4 times 1, which is 4. So negative y squared will be 0. Y squared will be 0, which gives us y equals 0. Now coming on over here and doing x is equal to positive 1, you may have noticed you'll get the same result, but I'll go ahead and I'll work it out for you. So 4 times 1 squared minus y squared is 4. 4 times 1 squared is 4. So we'll have that. So then we'd get negative y squared is 0, y squared is 0, and y is 0. All right, so what did we find out? We found out that we got 2 ordered pair solutions. So for our conclusion, what step was that? I think this will be step 3. So our conclusion is we get the ordered pairs, negative 1, 0, and 1, 0 as our answers, or as our solution set. All right, so the next one we've got A and B. Now be careful. This y variable is not squared in the first one, so we have to choose those x's to eliminate. So let's do this. We're going to do multiply equation A by negative 1 and add to that equation B. That will eliminate the x squared terms. So negative A is going to be negative x squared plus 2y is negative 8. And we are leaving B alone. So the x squareds will zero out. Be careful, those are not like terms. So we'll end up with y squared plus 2y is equal to positive 8. So if I bring the 8 over to the left side, I'll get this. So factoring, that's going to be y plus 4 times y minus 2 is 0. So you get y plus 4 is 0, or y minus 2 is 0. Y is negative 4, or y is 2. So then our next step will be, I'll put it over here. So our next step will be substituting in y is negative 4 and y is 2 into, let's do equation A, I think might be easier. So equation A was x squared minus 2y is 8. So we'll have for y equal to negative 4, we'll have x squared minus 2 times negative 4 is 8. So I just plugged in, where I saw the y, I plugged in the negative 4. So we'll get x squared plus 8 is 8, which gives us x squared is 0, which has a result of x equal to 0. So now let's plug in y equals 2. So for y equals 2, we're going to have x squared minus 2 times 2 is 8, which will give us x squared minus 4 is 8, which gives us x squared is 12. So this is what was plugged in this time. And then that yields a result of, if I square root both sides, we get x will be plus or minus. Now 12 is 4 times 3, so, and the square root of 4 is 2, so we'll get plus or minus 2 root 3. So let's see how we end up getting, wow, 3 results here, 3 results for this problem. So let's bring, I guess we'll bring our conclusion up here. I know it's a bit out of order, but the conclusion for this one will be, so we went over here, just so you don't get lost later. So our conclusion is we got the set of ordered pairs, 0, negative 4. We got negative 2 root 3, 2. And then we got positive 2 root 3, comma, 2. And that's our answer. You hanging in there? All right, so here we go. Part C. So for this one, again, I think if we go ahead and if we eliminate the x squareds, I think that would be ideal. So we would do negative 1 times equation A plus equation B, and that's going to eliminate the x squared. So that would give us negative x squared minus y squared is negative 4. That's negative 1 times equation A. Then we'll have x squared plus quantity y minus 3 squared is 9. So adding, the x squared zero out, and then we'll have negative y squared plus y minus 3, the quantity squared, is equal to negative 4 plus 9 is 5. So let's expand out the y minus 3 squared and combine like terms. So we'll have y squared minus 6y plus 9. That's expanding out y minus 3, the quantity squared. And all this is equal to 5. Well, this is kind of nice. The y squareds will zero out. So we're going to end up getting negative 6y is negative 4. So y will be negative 4 over negative 6. So y reduces to 2/3. So secondly, we'll substitute y equal to 2/3 into probably equation A. So now that would give us the original equation is x squared plus y squared is 4. So x squared plus 2/3 squared is 4. So I just plugged in the 2/3 for y. So that'll give us x squared plus 4/9 is 4. Subtracting 4/9 from both sides, we'll have this. Getting a common denominator of 9, we'll have x squared is 32/9. And square rooting both sides, we'll have x is plus or minus. Now, 16 times 2 is 32, and 16 is a perfect square. So in the numerator, we're going to have 4√2, and in the denominator, we'll have 3. All right. So our conclusion will be we ended up with what? 2 order pairs. So negative 4√2 over 3, comma 2/3, and positive 4√2 over 3, comma 2/3. The graphs intersect at those 2 order pairs. All right, so next up, let's talk about some applications. So let's figure out what's going on here. So we have the difference between the squares of 2 numbers is 5. Twice the square of the second number subtracted from 3 times the square of the first number is 19. Find the numbers. So let's just start out. Why don't we let x be the first number, and let's let y be the second number. So this is part of our analysis piece. So secondly, we're going to translate this into math. So the difference between the squares of 2 numbers is 5. So x squared minus y squared equals 5. Then twice the square of the second number subtracted from. So subtracted from tells me that guy is second. So I'm going to say twice the square of the second number is subtracted from 3 times the square of the first number. And the result to that is 19. So now we just need to solve. So first off, you need to write your system, which was x squared minus y squared is 5. And we had 3x squared minus 2y squared is 19. And if I name this guy A and this guy B, we'll be good to go. So I think I'll solve this one by, it's up to you. Do you want to use elimination? If we do elimination, we could multiply A by -2. So -2 times A plus B, that's going to eliminate the y squareds. So we'll have -2x squared plus 2y squared is -10. And then we're not changing B, so we'll rewrite that. So this is going to give us a result of positive 1x squared is equal to positive 9. And then if we square root both sides, we get x is plus or minus 3. So now if we go and we say substitute x equal to -3 and x equal to positive 3 into equation. Let's see what'll be the easiest. What equations do we have? Probably equation A. So equation A was x squared minus y squared equals 5. So for x equal to -3, we will have -3 squared minus y squared is 5. So I plugged in -3 in for x this time. And that'll give us 9 minus y squared is 5. Negative y squared is -4, which is y squared is positive 4. So square rooting, we will get y is plus or minus 2. Okay, now you may have noticed that plugging in x equal positive 3 will yield the same results, but just in case you didn't, I'll work it out for you. So we get 3 squared minus y squared is 5. 9 minus y squared is 5. Negative y squared is -4. Y squared is positive 4. So y is plus or minus 2. So this is what I plugged in the second time. And it was, a similar solution process. I just square rooted both sides here. So what did we find out? You end up with, 4 possibilities, right? So for our conclusion here, do it at the top. Conclusion. The numbers are we could have 3 and 2, 3 and -2, -3 and 2, and the other possibility is -3, whoops, and -2. They all will satisfy the system. Okay, so that wasn't so bad, right? All right, let's go on. This is our very last example here. So find the length and width of a rectangle whose perimeter is 40 feet and whose area is 96 square feet. So first off, let's figure out what's going on. So if we let x be the width and y be the length. And, you know, we have a rectangle. So here's my x and my y. We know inside area is 96, and we also know area is x times y, right? We were given information that the perimeter was 40, and we know perimeter is 2x plus 2y. So we've been given that 40 is 2x plus 2y. And I can simplify that a little, can't I? If I divide both sides of the equation by 2, I'll get 20 is x plus y. So let's translate this into an equation or a system. So we know that x plus y is 20 from working with the perimeter. We also know that x times y was 96, right? So that's our system. So let's solve it. So we had x plus y is 20, and x times y is 96. You can call this one A and B. So here we go. I'm thinking, why don't we do this? Why don't we isolate x in equation A? So if we do that, we'd have x plus y is 20. So x would be 20 minus y. So now we'll have to plug that into the equation B. So secondly, we'll have substitute x equal 20 minus y into equation B. So equation B is x times y equals 96. So we're going to have 20 minus y times y equals 96. So that will give us 20y minus y squared equals 96. Getting 0 on one side, we'll have positive y squared minus 20y plus 96. Now, I know that 8 times 12 is 96, and 8 plus 12 is 20. So we'll get 0 is y minus 12 times y minus 8. So y minus 12 is 0, or y minus 8 is 0, y is 12, or y is 8. Okay, so now, thirdly, if we substitute y is 8 and y is 12 into equation B, which is that area, x times y is 96, we'll get, for y equal to 8, we'll have x times 8 is 96. So x would be, lo and behold, 12. For y equal to 12, do you see it'll be the other way around? We'd get x times 12 is 96. So x would be equal to 8. So you just, to give the overall dimensions, you could answer in your conclusion that. I think they just asked for the length and width of a rectangle. So you could have, if we put for our conclusion, so a rectangle with dimensions 8 feet by 12 feet, or 12 feet by 8 feet will work. Okay, so I believe, holy moly, we're all done. All right, so have a fabulous day and make sure you do your homework, and I'll talk to you soon. Bye.